The mathematical modelling strategy I approached for this investigation involved a lot of trial and error in order to find a suitable solution. The Konigsberg bridge problem became an ongoing investigation, which Leonhard Euler discovered a suitable solution to end the misery. Unfortunately, the Konigsberg bridge problem cannot be achieved, as it is impossible to cross over each bridge once, as you will always have to cross at least one bridge twice. However, Leonhard Euler's solution gives some peace of mind. When approaching this investigation, all ends of the spectrum were considered in order to put forth the most appropriate and logical mathematical modelling approach. I decided to print several copies of the bridge problem in order to plan the journey where my pen never leaves a page, creating rhythm and flow. Here is a demonstration of how one pencil stroke has to go through one of the bridges twice. As you can see, the island is separated by 2 islands, however connected by 7 bridges. The islands are marked alphabetically in red, and the bridges are numerically in purple. After many attempts working this strategy, I began to notice that I was always crossing at least one bridge twice, typically this one, or this one. Therefore, I began to reference Leonhard Euler's approach by appointing 4 vertices acknowledging the 7 arcs, the vertices being the pi's points and the arcs being the purple numerical numbers. Through initiating this, it was understood that in order to have an odd vertex, you would have to begin or end at that vertex. Considering there can only be one beginning and one end for the bridge problem to remain impossible, there would have to be no odd vertices, as this would create an inability to trace over every bridge. This type of networking is called topology. The concept of topology aids in the completion of the bridge problem, as it includes a configuration of points arranged into islands and arcs. This understanding leads us to comprehend that in order for the Konigsberg bridge problem to be achieved, another bridge would have to be included in the equation. By doing so, Euler was able to determine a technique that would be utilized in order to trace a suitable solution, however, still crossing one of the bridges twice. In theory, every vertex with an odd number of arcs attached to it has either the beginning or the end of the pencil bar. Therefore, it is impossible to draw over all 7 bridges with one pencil stroke, as you can only have up to 2 odd vertices. The bridge problem is what is known as a network, where a figure is made up of points and non-intersecting curves, the arcs. Thus, in order for the bridge problem to be possible by crossing over each bridge once, Leonhard Euler's approach to this investigation became most logical, the degree of a vertex. In order for the Konigsberg bridge to become possible, the implementation of a bridge nearest to the points 4 and 5 would be most suitable. I've implanted a bridge between 4 and 5. Now watch. Thus, Leonhard Euler's solution was correct. Only with the addition of one extra bridge could it be possible to cross each bridge once and only once.